So like some of you noticed on your cume, you had this new question, multiplicative structure. First, before I even teach it, do you happen to know what that is? I'm just putting it out there. See if you already know it. Well, that's it, okay? You got it. When you go from left to right for each corresponding ratio, you'll notice you're multiplying by the same number all 5 times. What number is that? Does everybody see it? 1 times 3 obviously is 3. 2 times 3 is 6, and so forth. So we say that the multiplicative structure of this ratio table is times 3. Or if you even want to write it out, you can, so it doesn't look like an X. Not to be confused with constant. Because constant, I don't know if you remember this back when we did lessons 1 and 2. Here you had a constant of, now I'll think what 1 times what makes 2? Times 2. When you went from here to here, you had a constant of, constant of, constant of. Multiplicative structure never changes when you go from one part of the ratio to the other. What gets confusing for you guys is that this 1 to 3 is the same as when you write it as a fraction like this. That's where it gets confusing. Sometimes you see them horizontally and sometimes you see it vertically. So always say to yourself, okay, what's the ratio? The ratio is 1 to 3. You can express it this way on a table, or you can express it this way, top over bottom. This one is 2 to 6. This one's 3 to 9, 4 to 12, and 5 to 15. So look, but look what happens. Now, because you've expressed it top to bottom, multiplicative structure doesn't change. 1 times 3 is, 2 times 3 is, 2 times 3 is, 6, 3 times 3 is, 4 times 3, and 5 times 3. Squeezing it in here. That multiplicative structure never changes. Okay, so putting that into words, the amount of yellow paint on the right-hand side is 3 times more than the amount of red paint. Sebastian. Actually, yeah, do the dot. I like that because you're going to see that more and more, and you're actually going to see it a different way, which I'm going to introduce it in the next, if not this period, definitely period 5. Take a minute, though, just to read this statement. Yellow paint is 3 times more than the amount of red. Does that make sense to you? Does that resonate with you? Because you have to kind of get that into your head before we take this lead. All right, you ready to move on? You're going to write your first equation. What if we're given an amount of red paint that we're just going to call R? We're giving it the variable labeled R. That's listed here. How many gallons of yellow paint would we need? So in essence, what I'm asking you is the amount of yellow would equal what in R? That's the lead. And if you get hung up, go back to the table and say to yourself, okay, look, here's my variables. I have them here, Y and R. This Y3 equaled what did we do to R to get it? Sometimes it helps to work backwards, which I'm going to show you here in a minute. Will, I'm going to go to you. Does everybody see? You would have to figure out yellow, which is 3. I'd have to take R and multiply it by 3. So when we write that as an equation, y equals 3 times, here comes the dot. Ready, Sebastian? Here it comes. The dot now means to multiply. Get used to it. And I'm going to show it to you in even another way, and you'll be like really, really cool mathematicians if you can remember this. But that means that the amount of yellow is 3 times whatever how much I have for this unknown variable called red, or R. Now, I would be really impressed, before I give you the answer, if you could tell me how you would write this completely algebraically. Because you're going to see it in the coming weeks with no symbol at all for multiplication. Does anybody know how to rewrite this completely algebraically? I would be impressed if you can do it, because I don't think you've seen it yet in elementary school. You're so close. Brando. Ready? You were close. You had the right idea. Y equals 3R. Raise your hand if that's new to you. You've never seen anything like that before. Okay. So, I'm going to kind of introduce it slowly throughout the course of this lesson. But what that simply means is when you see a letter next to a number, and that number's first, whenever you see a number and a letter together, it always means to multiply those two things together. So we're definitely not going to use 3 times R anymore. Why? Definitely not going to do that anymore. I may still use the dot, but this gets confusing. Does anybody know why? Ellie.
It would look like X times.
You got it, exactly. X, as we get more and more algebraically savvy, which means more familiar with it, we don't want to get the times symbol, that multiplication symbol, confused for the variable x. So we eliminate that times symbol, that multiplication symbol altogether. You may still see it as a dot, but I don't like dots either. Why don't you think I like the dot? I bet you know.
It would look like a decimal.
You got it. It looks like a decimal. Because eventually you're going to see 3.5 times R. And that means 3.5 times R. It doesn't mean 3 times 5 times R.
But how do you not know that it's 3.5 R?
It's a new language that you'll eventually get used to. It is. It's the same reason why you know when you see the letters W-A-L-K together, it means to do this, to walk. It's a language. You just learn it, and it will become very familiar to you by third, fourth quarter. You'll just get used to it. You'll see 3R, 5X, you'll know it means to multiply, hopefully. Okay, so that's my little sneak preview into algebra. Going back to what we're doing, though, do you understand, let's go back to using the dot, that the amount of yellow is going to equal 3 times whatever I have for R? Yes. What you can do if you get confused, and I want you to always do this, is we're going to use substitution to prove that the equation is true. Okay, so if you go to the next page, here's what we're going to do. I want you to rewrite the equation we formed on the previous page. I'll use the dot. I don't want to confuse you just yet. I just don't want you to use the X right now. I want you to use the dot. And just know that that dot means to multiply. We're going to see if the equation works. So I'm going to take my first value, my first ratio. What was the value for y in that first row? Meals. I'm going to substitute where I see my y. I'm going to put a 3 here. Then I'm going to just bring down my 3, which is called the constant. or the multiplicative structure, I should say. I don't want to say constant because it's going to confuse you, but it's the multiplication number. And then what was the value in that first ratio for R?
1.
I'm going to substitute 1 in. Is 3 equal to 3? That way, we now know that this equation works and the equation is correct. Let's try it for one more other set, because if the equation works for the first set of values in the ratio table, it should work for any. Rewrite the original equation. Pick any set. What do you want to do? You want to do 2 to 6? You want to do 3 to 9? Pick one. Lex, yeah. Let's do it. That's what I was going to go with. All right, ready? What was the value for y, Alexa? What was the value for r? Evaluate this side. Is 3 times 4, 12. That's why the equation is good. That's the gist of lesson 13. I'm just going to give you different ratio tables now, and you've got to come up with equations. But you'll see when we meet back after lunch, we're going to go the opposite way. And here's a little sneak preview. If I wanted to create an equation for r, so instead of saying doing y equals 3r, and I do r equals, that's what you got to think about. R equals what? We're going to stop. I want you to think about it. Put some food in your belly, and we'll come back and discuss it. Where we left off. So now that you're back after lunch, just a quick recap again. What was the equation that we formed for y to figure out r for red? Y equals
r times 3.
Okay. So second part of this is if I had to create an equation for r equaling something, what would that equation be? And let me introduce it by doing it this way. You agree that if we go from here to here, we're multiplying by a factor of what, everybody?
3.
Times 3, right? What do I have to do if I go the opposite direction? This one I want you to raise your hand for. If I go left to right, and each time I'm multiplying by 3, what am I doing each time that I go from right to left? Does everybody agree divide? By how much? By 3, okay? We say that multiplication and division are called reciprocal operations. It kind of means the opposite. So I'm assuming that you've learned in elementary school that multiplication and division are reciprocal operations, even though that word might be new to you. What are the other two reciprocal operations? Shane? Addition and subtraction, right? They're reciprocal operations, opposites. So, what do you think, if we create an equation for r, what do you think the remaining part, or the right side of that equation should be? And you just have to be careful because order matters in division. It doesn't matter in multiplication. I can go, going back here when we created this equation, I could go 3 times r or r times 3 and I'd still be okay. The order matters here if we're going to use division on the right side of that equation. What do you got? Go ahead. Come on, help me out. You're halfway there. Yeah, give it a shot.
R equals 3.
Okay. How can we prove that that equation will work? What did we do to prove that the other equation worked? What did we do to prove that this worked? What can we do?
Go back to the chart and see what works.
What's the S word I used? I'm going to be using it a lot. Starts with an S, second letter is a U. We can, you, Jen, you had your hand up. Not subtract. We can substitute the values for R and Y to see if the equation works. So let's do that. Take the first set of values. I hate scrolling back and forth, but I'll try to keep it on the same page, even though this is a little bit lower. Okay, ready? For, again, this set of values, guys. What was the value for R? Somebody, come on, help me out here. Brando. Which one are you doing? This one? Start with, all right, let's do this one. Fine. Okay, I'm going to put 4 in for R. 3 divided by, what was in that same row, what was the value for Y? Ready? Is 4 equal to 3 divided by 12? Yes or no? Say it. You be careful. 3 divided by 12?
No.
Order matters. Come on now. 3 divided by 12 is not 4. But what is equal? 3 divided by 12 is not 4. What's our issue? Because we almost have it. So, yeah, the 12 and the 3 have to be switched. Is 12 divided by 3 4? So what do I have to do to my equation to make it true? R equals what? Y divided by 3. Let's see if it works. And we'll pick another set of values to see if it does. What set do you want me to do? Come on, get out of your lunch coma, guys. Get the brains going. Connor, give me a set. Do you want to do a 5 to 15? We already did a 4 to 12. 3 to 9? Pick me a set. All right, we'll do 2 to 6. Ready, Con? And that 2 to 6, what's the value for R? Look, bud, it tells us. What's the value we're giving for R? Because you just called it out. That's my Y. Right. Substitute 2 for R. Equals, what's my value for Y? Right. Ready? Is 2 equal to 6 divided by 3? Our equation for R will work. So we formulated a second equation. We have 1 for Y, which is Y equals 3 times R. And we have now 1 for R equals 3 times Y. 3 divided by Y, so sorry. Are we okay with this? I know we need to practice it, but you sort of get it. We have to practice it, and we will. Believe me, we're going to spend a week practicing it so it becomes familiar to you. We have one more other little small leap that we need to make. Dividing by 3, which is what this is the same thing as multiplying by what? If I told you that you had to form this same equation, but this time you've got to use multiplication, what would you have to multiply by? And you know what? Let me see if this helps you. Let me take these values. 2 equals 6. I'm just going to substitute back in. Times what? 6 times what would make 2? I want you to think. Would it have to be 6 times? Would it be crinkling? All right. 6 times. Would that value have to be a value that's greater than 1 or less than 1? Addison, how many think less than 1? How many think greater than 1? All right, so we're in agreement. 6 times some value less than 1 has to make 2 because the number's getting smaller, right? So now we got to start thinking, okay, less than 1, we're thinking fractions. 6 times what makes 2? Ava, take a stab. What do you think? Close. If it helps you, half of 6 is 3. It's not 2. Let's see if it works. You guys know how to multiply fractions. Did you learn that? Did you learn about how to take a whole number and make it improper? What goes on the bottom? Okay. What's 6 times 1? That's 1 times 3. What kind of fraction is this? Did you learn what kind of fraction this is? No, but improper because it's top heavy. 3 goes into 6 how many times? Guess what? Ava's right. 6 times or y times a third is the same as. So if this helps you, you've created what's called reciprocal operations, but you've also created what's called reciprocal numbers. Told you this was going to be elite. So dividing by 3 is the same as multiplying by 1/3. Oh. Let's practice. Let's do one more together. You guys have lunch coma. I can tell. All right, let's do what we can do. If we're going to struggle through equations, we'll do it. We'll struggle together. But you can definitely do equivalent ratio table construction. So read through the problem, and let's at least get the equivalency ratio table done. Take about a minute or two, and then I'll call somebody up to do the values. All right, value of the ratio first. And for now, let's just make believe the total's not there. Between red and blue, what's our value? Carly. 4-1. Multiplicative structure, and look what's going to happen this time. I'm going to go this way. Just so it's easy to see. All of those times I'm multiplying by what factor? Shania Quinto. Okay, so we say it's a multiplicative structure of times 4. Now, I want to kind of do this in reverse because in number 2 ask you to do an equation for red, and I actually want to start and do an equation for blue. I think it's easier, but I need to get out of full screen and rely on you to use the data table or the equivalency ratio table so I'm not scrolling back and forth. So skip number 2 for now and let's do 3. Or I'm sorry, skip number 1 and let's do number 2. Write an equation that will let Jorge calculate the amount of red. So I have red here, so it's going to be R equals something. What goes on the right side of that equation? Use multiplicative structure in your answer, because that helps you a whole lot. Jen. Times You got it. Let's see if it works. Let's do a mental check. We won't actually substitute written, but let's just see if it works. Okay, ready? Give me a value, Sebastian, for R that you see in the table. 12. Okay, ready? 12. I'm going to put 12 here. Is that equal to 4 times B in this case, which is 3? Is 4 times 3 12? Equation works. Equation works. And it will work for any set of values that you pick. If I pick 20, 20 becomes my R. I'm just going to bring this down. Substitute this in. Is 20 equal to 4 times 5? Obviously, yes. Equation's good. Let's reverse it. What if I now want to figure out blue paint? If you have trouble with that reciprocal fraction, keep it division. Because if you're not ready for it yet, so be it. You're not ready for it yet. But I now have B on one side, and I know I've got to have a Y here on this side, but I've got to do something to it. What do I got to do? Oh, that's, okay, sorry, not Y. It's got to be, in this case, it's R. Sorry, red is, sorry, we're not doing yellow, we're doing R. Sorry. Thank you, good catch. What do I got to do to the R? Light bulb? No, you tell me. Let's see if it works. Give me a set of ratios. All right, 16 to 4. 16's the R, right? That goes here. 4 is the B, right? 4 equals, or does it equal, 16 divided by 4. It works. Equation's good. It's going to take some time to practice it. I guarantee some of you will get it right away. Some of you will struggle through it. We'll get through it. We're going to practice it. Basically, the rest of the period is yours to get through what I have assigned for homework. Here it is again. You guys are going to do 7, 8, and 9. There is a page 6, but I'm going to skip it. Absolutely not. You got to pay the toll first. $5, please. Ting. Okay, go ahead.